make sure that all nodes in the cluster have the same set of configuration information, right? So they use an XML kind of definition internally to distribute between the nodes and synchronize what the cluster configuration is, what services are running, where, and what's the status of those services. That's done with the cluster information base. Then we also have the cluster resource management daemon, which basically takes care of resources that are registered into the cluster, so that they can be queried and moved around between it handles moving around services, creating a service over here, bringing it down over there. Any changes that might be made to the configuration kind of go through this CRMDB process. And then the last major component is this thing called CoroSync. And you can kind of think of CoroSync as your data bus or your message bus, if you will. That's where your cluster to cluster, member to member communication needs are to establish, this high availability cluster, right? So it keeps components communicating and also serves as kind of the centralized membership, if you will, of the cluster. So that's really all I wanted to go into from this, because like I said, the bad news, it does make the environment a little more complex. And so what the good news is that the Power VC team, the development team, has wrapped all this with all the tooling that comes with Power VC 2.02. So the installation process of creating the cluster and configuring it and operating it and bringing it up and down and changing nodes and all these things, it is all built into the commands that Power VC is providing you. All of these other functions underneath the covers with the pacemaker is kind of handled by these commands. And then the other thing I wanted to mention is, in addition to this clustering technology for high availability, there's also a new monitoring capability that is now packaged with Power VC. I'll go into that a little bit more in a few more slides down the road toward the end, but basically some new package capability and configuration that'll help you monitor and maintain a healthy cluster. So let's jump in. Let's look at the setup and the architecture a little bit closer on the control plane. So this Power VC multi-node architecture, if you take a look, like I mentioned, there's a 3-node configuration. So we have 3 Power VC nodes. Each of these Power VC nodes really is configured to run all of the services, right? So they all have configuration information and they run services that we're all familiar with. If you've ever done any debugging, you've kind of gone in and looked at logs or whatnot. You might have seen, some of these. So the typical Cinder services, Nova services, the MariaDB under the covers, the RabbitMQ messaging services, all of these run in all 3 nodes. And then the service itself is kind of hidden behind a proxy. And then, so we use HA proxy to kind of surface a virtual IP address, if you will, so that all requests into Power VC come through this virtual IP address, and then under the covers get routed into the proper PVC node, Power VC node. And then, of course, cluster services itself is managed by Pacemaker and CoroSync itself. So we look at the top, your typical, browser access into the Power VC GUI, that is now pointed to a virtual IP address. And so that then in turn, pops down into HA proxy, and all the HTTP services respond back up through appropriately to your browser for the GUI. The REST API calls, whether they be OpenStack calls or some other Power VC, service call, again, those are pointed to the virtual IP address and are serviced by underlying services through HA proxy. And then if you have any other, integrations above Power VC, other cloud products that have been integrated in using the OpenStack APIs, those again can point to this virtual IP address and have a high availability cloud, basically Power VC providing a high availability cloud for that. One other thing I want to point out here is if you look at the lower left-hand side down here, Ops Manager for multi-node deployment and monitoring. That is a new process that has been packaged with this version of PowerVC 2.02 and handles all of the installation and configuration of both a single node and a multi-node configuration of PowerVC. So when you're looking at that, it's going to handle all those activities and maintenance activities. Everything else just communicates as normal, runs as normal. When you're looking at the GUI, when you're looking at REST API calls, you really don't see any difference. You point to a virtual IP, everything else operates and runs as it always has. So no change from an end user perspective. We'll get into a little bit more, but NovaLink in that environment, same scenario. NovaLink works on the virtual IP address basis. So all communications of services between NovaLink and the control plane, the main control plane cluster, all happen through virtual IP as well. One thing I'll just mention because it's on the slide, there's a Cinder backup up here on the left. And I'm not going to go into this feature specifically, but just wanted to let you know that you can define such a thing as a backup node that is outside of your cluster, if you will, outside of the PowerVC cluster itself to address, creating OVAs and things like that and backups of images in and to be imported and exported out of PowerVC. I want to mention that. Feel free to go read more about that, but just gives you a way to define a node outside of your typical PowerVC services that maybe you have fiber channel attached where PowerVC is not, right? That needs to do export and import from storage. So I'm kind of solving that problem there. Just want to mention it because it is on the slide. So if we take a look at this Ansible-based PowerVC deployment, as I mentioned, with this new Ops Manager component, does several things. So it will install all the services both into a single node configuration or a 3-node configuration. So it handles running playbooks to lay software on top of the operating system. So, one of the prereqs is you have to have 3 nodes installed with Red Hat. And then the Ansible-based playbooks will handle installing any prerequisite software from Yum repositories, as well as laying down this multi-node HA software, configuring the software, setting up the load balancing across the 3 nodes, and setting up the virtual IP address configuration as well within each of these nodes. So let's look at the requirements a little bit to get this capability. As I mentioned, we need 3 separate virtual machines, or they can be physical machines as well. More these days are typically VMs. Can run on Power 8 or above. Does require Red Hat 8.4 because of the dependency of using kind of the prepackaged high availability add-ons, the pacemaker software. It is PPC 64 LE only. We've dropped the big Indian support. We're going with just little Indian going forward. You can run it on x86 based servers. There again, RHEL 8.4 it would be required on that as well. You want to install the Red Hat server or server with GUI additions. I mentioned VMs are bare metal. All of the 3 nodes must have the same configuration. What I mean by that is the same version of operating system, patching, CPU configuration, memory configuration, and disk configuration. You want to have all of those in sync so that all services and operations run the same, and expectations are the same on how they're to run in the cluster. Currently, the multi-node support is only available in the PowerVC for Red Hat 8.4. You can still run PowerVC version 2.02 on SLES, SLES 15, Service Pack 2, or Service Pack 3. However, it is only would only be configured and supported in this single node configuration. So that's the only way it would install on a SLES. It is still using the Ops Manager process, but it will just install as a single node on SLES. We look, this table is directly from the Info Center. Again, I snapped some of this before GA. So please go out to InfoCenter if you're interested in installing PowerPC multi-node or